So this is the last part of our solar, the steady state building load calculations, and where we are going to take into account the internal loads. So in the previous two videos, what we have considered is, we had considered the transmission loads and we had considered the solar loads. In this, we are going to take into the internal loads, and the two major internal loads which we have, as I described in the first video, introductory video on steady state building load calculation. The first is the occupants, and the second is electrical. Now, in this video, we are going to take into account both of this, because that's not much of calculations involved in occupants or electrical heat load. So for occupants, what we have is, we have both the sensible load and we have the latent load. And as I said earlier, it depends on the type of activity the person is doing. Activity and the number of people. So for the basic activities which are happening in our office buildings, that's the main base use case for us right now. For office building people which are just sitting, like typing and like maybe walking, speaking, the basic activities. For those, the sensible heat load, the basic standard value for sensible heat load is 255 BTU per hour per person. For latent, and this value is equivalent to maybe 70 watts per person. That's the sensible. And the latent part is close to 103 BTU per hour per person, and that's approximate to 30 watts per person. Sorry. Okay. So if we want to calculate the occupant heat load, and that's always the heat gain to the building, because occupants are going to release heat, sensible heat and latent heat. The latent heat means whatever perspiration is happening, whatever sweats we are getting, that's the heat load, latent heat load. So my Q sensible from occupants will be, let's say in our building we have on an average 700 people. Average occupancy in a building is 700. So what I'll have is, the sensible heat gain will be 255 BTU per hour per person. Sorry, just take it as R into 700 people. So my value would be 255 into 700, and my Q latent from occupants will be 103, and this value will be in BTU per hour. That's very important. Writing units is going to be extremely important in this module. Into 700 people will be some value in BTU per hour. And that's how we get the total sensible occupant load and latent occupant load. Now, to look at the electrical load, that's all we have with respect to occupants. It's very simple a calculation. That's no specific about orientation and all, and nothing comes in like what we had in our solar load or transmission load. And for electrical also, it's exactly as simple as we have in occupants. What we need is the type of equipments, that's the first factor. Over here the two factors were the activity and the number of people. Over here we have the type of equipment and the time of use, duration of use. So let's say we have fans, computers, and maybe the exhaust fan will also come into account. Then we have mobile phone chargers. Then we have fax printers, copiers, coffee machines, and all. What we just need is we want to take the power rating of those, the rated power. So maybe the fan is using 20 watts or 200 watts or 2000 watts, maybe 2 kilowatts. Computer is using 250 watts. The mobile phone charger uses 15 watts. The printer are using 200 watts maybe. And these are just estimates. I don't know the actual value. And let's say we have the use of fan happening for around 15 hours a day. Computers are used 24 hours a day. It's not ideal, as and when the people should leave the office, they are expected to turn off the computers. But if they do not, we'll take the amount of time they are using. The mobile phone chargers are like 2 hours a day. Fax and printers are like 1 hour a day, and etc. What we just need is we just need to multiply those two values and get our value. So 15 into 230 kilowatt hour. And the complementary values could be in BTU per hour also. BTU per hour. This is watts. This could be 25 into 24 kilowatt hour. Watt hours. And similarly, then we just need to total it up. And the value which comes out will be the Q due to electric. And it's obviously the sensible part. That's no latent part. So the latent part only comes from the occupants and the infiltration, which we have covered already there in the solar load. That's all we have with respect to the internal loads, the occupants and the electrical load. That's two major contributions to my internal loads. Thank you and have a nice day.